गुड इवनिंग बच्चों। गुड इवनिंग एवरीवन। I hope we are live. Everybody please be active in the chat box and please let me know, am I clearly audible and visible to everyone or not? Yes, after so long I'm here on this YouTube channel, and my entire team is going to bring a very beautiful series, and this series is going to be very helpful for those people who are looking forward for GATE 2027. What we are going to do in this beautiful series, we are going to cover all these subjects, है ना, in the shortest possible way. Like in theory of machine, the very starting subject, today is the first lecture of that long series. For theory of machine, I have dedicated almost 13-14 sessions, and in these 13 or 14 sessions, what we are going to do, I'll be taking daily 2 hours class, this 8 p.m. to 10 p.m. and in each class, almost every class we will be finishing one chapter in such a manner that those who have already studied things, it will be a good way to revise things. Those who just want to explore what is GATE, for them I will give you a clear idea that in this particular chapter, like today I'll be talking about simple mechanism. So in simple mechanism, what are the key areas from where questions are asked? You will be getting a glimpse what simple mechanism is, and in this entire big chapter, what are the key aspects from where questions are framed. And to explain things, I'll be taking help of some questions, and to make this series even more relevant, the questions I have picked are actual PYQs. And so while you are watching the concepts and doing the practice, so you are actually doing actual questions ka practice which have really been asked in GATE. So you will be getting a taste of what GATE exam is. ठीक है ना? And this series is going to be entirely in English. So all those people who are not from Hindi speaking states, they can learn a lot from this. Shall we begin? So today, the very first chapter, I am talking about simple mechanism. I'll be covering theory of machine and vibration both, है ना? Theory of machine plus vibration I'll be covering, and today we are talking about the very first chapter, simple mechanism. Simple mechanism क्या होता है? What is a simple mechanism? And in this chapter, what key concepts I'll be discussing. Exams mein they can ask questions very frequently. They have asked question first of all on what is the degree of freedom. They will be giving you some mechanism and they will ask ki a mechanism is shown, tell me what is the degree of freedom of this particular mechanism. Degree of freedom, or we can also call it as mobility. So what are the formulas which govern the degree of freedom? I will discuss that. What are the some tough questions wala point? I will also discuss that. Where most of the students are doing mistake, I will discuss those areas also. So degree of freedom is quite frequently asked. Second thing, sometimes they ask question based on Grashoff's law. So what is Grashoff's law? What does it says, where it is applicable, and how questions will be asked on this Grashoff's law? I will also discuss this. Then there is something which is called as quick return motion mechanism. Quick return motion mechanism. There are basically 3 types of quick return motion mechanism which we study in our syllabus. We have crank and slotted lever, quick lever, crank and slotted lever, quick return motion mechanism. Then we have Whitworth, and then we have offset slider crank mechanism also. Questions have been asked in the GATE on all these three, quick return motion mechanism. The most important is crank and slotted lever. I will discuss, all these three: offset slider, crank mechanism. And then last, questions are also asked in what is the mechanical advantage. So if you are, just revising this chapter, so these are the key areas from where questions have been asked. Okay, so you must know what is these things. Chalo, give me a little glimpse. How many of you have heard about these things already? How many of you have already studied this chapter, so that I can decide what will be flow of my, this lecture. If you people have already studied things, so it will be quite easy for me to cover things fluently. Chalo. First of all, let me give you a little glimpse. What is mechanism? बहुत ध्यान से समझिए. Whenever I am talking about mechanism, and in our syllabus, we actually have simple mechanism. Sir, there will be so many mechanisms which are having larger number of links, but our study is restricted only for those situations where we are having 4 links. Simple mechanism is, it is something which is made up of 4 links and only 4 lower pairs. 4 lower pairs only. So I'll be restricting my, discussion on this situation. But sir, apart from this, do we have mechanism? Yes. Market mein there are 3D mechanisms also. Market mein there are mechanisms where number of links may be 6, 8, 10, 11, 15. More number of links can be there. But we are focusing only for 4 links, 4 lower pair mechanisms. And these lower pairs can be anything. Lower pair ka matlab hota hai, whenever we are having a kinematic pair having surface contact. So that is something which is called as lower pair. And that lower pair, generally we, in 2D mechanism, generally we see these lower pairs either in the form of turning pair or in the form of sliding pair. So what this lower pair exactly is, it can be anything. It can be turning pair or it can be sliding pair or a mixture of both. We may have only turning pairs, we may have few turning pairs, few sliding pairs. Okay. So what is this simple mechanism? I hope this is clear to everybody, that we will be focusing only on those mechanisms where 4 links are there. They are connected with the help of 4 lower pairs. I'll be discussing about this, but let's decode this a little more. So no, we are actually surrounded by so many machines around us. Just look around your room. We have so many things. We have a revolving chair, that is also a mechanism. We have a table fan, that is also a mechanism. I have a cycle at my home, a mechanism. I have at my door, I have a automatic door closer, that is also a mechanism. I have a car, bike, that is also a mechanism. Or in fact, car, bike, these are some very big machines which have so many mechanisms working together. If I'm talking about my car, so my car has gear train. There are so many gears. Gear train, it is a mechanism. We have steering. Car may we have steering mechanism. We have, for applying the brakes, we have brake mechanism. So there are so many mechanisms. We have on the windshield of the car, I have a wiper system, so that rain's droplets can be washed away. So for operating that wiper, I have a mechanism. For doors, locking and unlocking, I have another mechanism. For rolling down the window, there is manual. If you are talking about manual, window glass, so you have something which you roll down like this, and your glass goes down or goes up. So it is also being governed by some mechanism. I have something, I am providing input here, and my glass goes up, or anti-clockwise my glass goes down. So how my rotating motion is getting converted into linear motion of the glass. So everything is governed by some or other kind of mechanism. So we are totally surrounded by mechanisms. Okay. So how any mechanism is going to work? Mechanism may we have the smallest portion, smallest movable portion of any mechanism, which is called as link. Link, or I must say kinematic link. Kinematic link. So I have some kinematic link. What is a link? Link means any small part of the mechanism which is having certain type of relative motion with respect to any other part of the mechanism. I will say that this part which can move with respect to some other part, it will be called as link. For example, if I'm talking about my IC engine, everybody might have seen. How does it look? So we are having a cylinder which looks like this. Cylinder looks like this. Sir, I have a cylinder, and this big cylinder setup, it is having a piston inside it. This is the piston, and this piston is connected to a connecting rod with the help of pin joint here, and this connecting rod is further connected to a crank, again with the help of pin joint, and this crank can have rotation with respect to this cylinder, and the cylinder I have kept fixed. So how many kinematic links you can identify here, sir? First of all, this fixed wala link, I will say that this is your link number 1. Link 1 के respect में this crank is rotating, I will say that this is link number 2. 1 के respect में body 2 is moving, another link. With respect to 2, connecting rod is also having some motion, sir. I have a pin joint here. Pin joint between any one link and link 2, pin joint is providing some motion. Pin joint is allowing some motion. So if between link 2 and this link there is relative motion, so both these will be called as different links. Link 3 can have, because of the pin joint, with respect to piston, it can have some relative motion. So link 3 and this will be your link number 4. So how many links you can see here? I am having 4 links. बात समझ में आ रही है? So we are having total 4 links. How many kinematic links? These are things which I am calling it as kinematic link. Clear है बात? अच्छा, to be even more specific, if you look at this crank, so crank actually looks like this. We are having a crankshaft. Crankshaft is having this. Let me draw in 3D. How does it look? We are having this crank. This is the crank. Something like this. This is the crank, which I am saying as radius R. That is actually this radius R. Crank is connected on the bearings. This is the bearing. Here also I have shown the bearing. So my crank, which I am showing here, this is my crank. This is something which I am calling it as crankshaft. It is a single part. On the crankshaft, further ahead, I have connected a flywheel. So that flywheel is mounted on this shaft, rigidly mounted. Rigidly mounted means, sir, there is no relative motion between this flywheel and this crankshaft. So this flywheel, so this entire thing which I have made using purple color, crankshaft, this is the crankshaft and this flywheel. All these 3 things are counted as single body, single link. Why? Because there is no relative motion between these 3 bodies. बात समझ में आ रही है? So I hope everybody is getting the difference when a part will be treated as a different link. For being called as different link, that part must have some motions. It must be having some relative motion with respect to other part. If I have 2 things, say for example, if I am having, this 2 pen you can have here, You are having these two pins. If I connect both these pins with the help of pin joint, I have a pin, and with the help of that pin, I have connected both these bodies. Because of the pin joint, between these two pins, I can have this relative motion. They can move. So I will say one link, another link. But what if I do welding here? If I weld this, now they are having rigid connection. There is no relative motion possible between these two bodies. So now this entire thing becomes one kinematic body. For me, it doesn't matter whether they were separate to earlier. Because of the welding, now they are having no relative motion. I will treat them as single kinematic body, single kinematic link, single kinematic element. I hope this is clear to everyone. So once we have the kinematic link, these kinematic links will be connected. And once you connect kinematic link in such a way that there is only constrained motion possible, that is called as kinematic pair. Kinematic links, connect them, join them, you will get kinematic pair. Kinematic pair. And what is the meaning of kinematic pair? Kinematic pair का मतलब होता है whenever two bodies are connected in such a beautiful manner that only desired motion is possible, constrained motion is possible. Say for example, if I am having a rectangular block, and inside this rectangular block, this is a rectangular block, and inside this rectangular block, if I have created a hole, and that hole here is also of the rectangular cross section, through hole I have, and this is one body. So this one body, and inside this body I am having a rectangular shaft. How rectangular shaft is going to look? So rectangular shaft looks something like this. We are having rectangular shaft which looks something like this. ऐसा कुछ दिखाई पड़ेगा बेटा. This is your rectangular shaft. Now imagine if I take this shaft and I am having a hole here. If I put this shaft inside that hole like this, can you imagine? Between this body 1 and this body 2, there is only one possibility of translation along this hole, along x-axis. So sir, only this kind of motion is possible. Doesn't matter. Even if you apply force in the y direction or in the z direction, even if you apply torque, there will be no random relative motion. So suppose if I want that between two links there should be only translation, so I can provide this kind of connection. So in machineries we prefer these kind of joints, these kind of pairs, and this is something which is called as kinematic pair. So I hope you have got an idea of what is the kinematic pair. Kinematic pair का मतलब होता है whenever we have connection in such a beautiful form that only desired motion is possible, only desired motion is possible. Motion means relative motion. Motion is possible. Then I call it as kinematic pair. So you are having kinematic links. What is the kinematic link? I hope you have got it. Now if you connect kinematic links in such a beautiful manner that only constrained motion is possible, doesn't matter in which direction you are applying force, only constrained motion is possible, only desired motion is possible, no other motion is possible. Even if you apply force, no other possibility. Sir, in the last diagram which I have shown, if you apply torque, sir, with respect to 1, link 2 will not rotate. Why? Because sir, the connection is not allowing that motion. This is something which is called as kinematic pair. And now if I connect, I have got the pair. Now if I connect link 1 to link 2, link 2 is connected to link 3, link 3 is connected to link 4, and last link is finally connected to link number 1 again. Yani ki first link is connected to the last link. I will get a kinematic chain. This chain. Acha, closed chain, first link is connected to last link, it will be called as chain. But for calling it as kinematic chain, there are some conditions that all the pairs which I have made here, and link 1 is connected to 2. So whatever pair you have got, this must be kinematic pair. Link 2 is connected to 3. Between 2, 3, this pair must be kinematic pair. 3 is connected to 4. That pair must be kinematic pair. So every pair must be kinematic pair. And the entire chain ka relative motion must be constrained. Then only you will call it as kinematic chain. Now I have got kinematic chain. All pairs must be, whatever pairs you have made here, all pairs, what is the condition? All pairs are kinematic pair. Number 1. And chain must have constrained relative motion. Chain must have constrained relative motion. Then only you will call it as relative motion. Then only you will call it as kinematic chain. And once you have the kinematic chain, I have found something which can be used to get a unique output by providing a single input. And that is something which is called as mechanism. How? If you are using this kinematic chain, so for using this kinematic chain, you must fix any one link. Like in this case, I was having a kinematic chain where link 1 के respect में link 2, link 2 के respect में link 3, and link 3 के respect में link 4. They are having some relative motion. So if you want to utilize this thing, you have to fix any one body. So here in this case, I have fixed the cylinder, and once you have fixed the cylinder, so fixed cylinder के respect में all these bodies are doing some kind of motion. Now it is called as mechanism. Fix any one link. Kinematic chain ka any one link is fixed. Fix any one link, you will get mechanism. Sir, is it necessary that always cylinder will be fixed? What if in this chain, if I want to fix the crank and all other links are moving, link 2 ke respect mein link 3, 4 and 1 they are moving? Is it possible? Yes, it is possible. Sir, if I want to fix link number 4, if I want to fix this piston, all other links are moving, will it be called as mechanism? Yes, it will also be called as mechanism. And whatever mechanism we are getting from the same kinematic chain by fixing this link or this link or this link or this link, there are 4 links, there are 4 possibilities. It's completely up to you how do you want to fix any link. I want to fix link 1. Somebody says I want to fix link 2. Somebody says no, don't fix these, I want to fix link 3. Or somebody says I want to fix link 4. So totally depends on you. Whatever you are getting, these are the different mechanisms, and these things I have got from the same kinematic chain. This is also called as, they are the inversions. These different mechanisms are called as inversions of the kinematic chain. Inversion क्या होता है? I hope you have already got it. और ध्यान से समझना. So say for example, I have 4 links. Out of these 4 links, how many types say I can fix the links? Sir, there are 4 possibilities. Link 1 sometimes, link 2 sometimes, link 3 sometimes, or link 4 sometimes. There are 4 possibilities of fixing the links. And maybe by fixing link 1, I have get something different. By fixing link 2, I have got something different. Link 3 को fix किया, I have got something different. So if I am getting different mechanisms, so they will be called as different inversions of the same kinematic chain. So how many inversions are possible? Sir, if I have 4 links, there are possibility of max to max having 4 types of mechanism. If I have n number of links, so how many possibilities? Sir, max to max n possibilities are there. So how many inversions are possible? Number of inversion, it will be equal to n. N links, so n inversions are possible. On the other hand, let me write it like this. For a chain, for a kinematic chain with n links, if I have n number of links, so how many inversions are possible? For a chain with n links, how many inversions are possible? Number of inversions can be n. But sir, what if you have fixed any one link number 1, suppose you got something, and by fixing link 2 you are getting the similar thing, then also you will call these two as different inversions? No sir. For being called as inversions, mechanisms must have, sir, by fixing link 1 I have got something, by fixing link 2 I have got something different. So if you want to call these two things as, these two mechanisms as different inversions, both these things must have some different type of motion. So there is possibility that any two mechanisms which I have got, they are the same, so they will not be considered as two different links, two different mechanisms, two different inversions. So what I'm saying, 4 link, max to max 4 possibilities are there, but if any two mechanisms are of the similar type, then number of inversions will be only 3. That's sir, either 1 or 2. By fixing either 1 or either 2, I am getting the same thing, so it will be considered as only 1 inversion. So that means number of inversions maximum is n, it can be less also. So number of inversions is less than or equal to L. How many of you can understand this? Hana? Everybody knows that maximum possibility is n, but actual we may have even less than n also. Yes, I have seen this engineering services mains ka paper was actually a good paper. For last so many years, whatever questions they have asked, this year questions ka level was a little up. Whether it was question of gyroscopic couple, it was a dangerous question. Governor ka question bhi, it was a dangerous question. And even the theoretical questions they have asked too much. So whatever we have studied in the classes, questions were actually from the notes. Okay, so I hope everybody has got this clear idea. Now let's move ahead. So what is kinematic link? Then we make kinematic pairs, then we have kinematic chain, and then finally we get mechanism. Which mechanism we are interested in? Sir, I am interested only in simple mechanism. I am interested in only simple mechanism. Now simple mechanism can be of how many types we may have? There is possibility of having 4 types. What are the types? We may have 4 bar mechanism. 4 bar mechanism kya hota hai bhai? What is the 4 bar mechanism? Sir, we are having 4 links and all the lower pairs are the turning pairs. 4 turning pair. All 4 pairs are turning pairs. Then there is single slider crank mechanism. Single slider crank mechanism. What is the meaning of this? Sir, single slider. Now, earlier I was having 4 turning pair, 1 sliding pair I have introduced. So this time I am having only 3 turning pair and 1 sliding pair. And then there is double slider crank mechanism. Double slider, that means 1 more sliding pair I have introduced instead of having turning pair. So now I am having 2 sliding pair and only 2 turning pairs are left. So using 4 links and 4 lower pairs, I can have these 3 possibilities. These are the 3 possibilities. First of all, let's talk about what is the 4 bar mechanism. Acha, chalo. Before talking about 4 bar mechanism, let's talk about any mechanism ka degree of freedom. They ask questions on the degree of freedom. What is the degree of freedom, beta? Degree of freedom is actually defined as number of, by definition it is number of minimum number of independent variable or parameters required to define completely motion of any system, है ना? This is the general definition of the degree of freedom. If I want to talk in terms of mechanism, degree of freedom is a general term. You might have studied this in fluid mechanics also. You might have studied degree of freedom in your class 12th physics. First time in your life, class 12th की physics में you have heard this term degree of freedom, and then you have heard in thermodynamics also, है ना? So different subjects में degree of freedom को I have defined according to my subjects, but the core philosophy is this, that if I have any system, so for this system's motion, if I want to define this system's motion completely, how many parameters, how many minimum variables are required, sir, that is something which is called as degree of freedom. Now for mechanism, what is the meaning of this? Mechanism ke liye there is a equation given by Sir 𝐂𝐬𝐬𝐞. This is the governing equation, 𝐂𝐬𝐬𝐞 equation. What is this equation? This equation says degree of freedom F is equal to 3L minus 1 minus 2J minus H. What is the meaning of this? What are the different terms? Here this F is the degree of freedom. L ka matlab hai this is number of links. How many links we are having? Number of links. J is the effective number of lower pairs. Effective number of lower pairs. How many lower pairs I have in the mechanism? And this H represents number of higher pair. Higher pair, those pairs which are having lesser contact area, point contact or line contact. Calculate all these things, put down the values, you will get your value of the degree of freedom for the mechanism. This formula is for 2D, or we can also call it as planar mechanism. What many people do mistake, they remember the formula but they forget that this formula is valid for which situation. So this formula which is given by Mr. 𝐂𝐬𝐬𝐞, it is only valid for 2D or planar mechanism. Okay. How we are going to use this formula? Listen carefully. Just for example, suppose if I am having a mechanism like link number 1 is connected to link number 2, link 2 is connected to 3, 3 is connected to link 4, and 4 is finally connected to link number 1. I am having this situation, है ना? We are having this pin joint, here also pin joint. So I am having these pin joints. This is a chain. Any one link must be fixed. Then only I can call it as mechanism. So suppose I have fixed this link. Now this is the mechanism. Find out degree of freedom of this mechanism. How can I write degree of freedom? Sir, degree of freedom ke liye I will say, first of all, count how many links we are having. So I am having fixed wala link number 1, link number 2, link number 3. This is my link number 4. How many links we are having? I am having 4 links. How many pairs, lower pairs we are having? Turning joint, turning pair, count karo kitne bhai? Sir, I am having 1, 2, 3, 4. I am having this lower pairs are equal to 4. Do we have any higher pairs? Or there is no higher pair. All the pairs are turning pairs are lower pairs. है ना? So how many higher pair? There is no higher pair. Put these values. Degree of freedom कितना हो जाएगा? What will be degree of freedom? 3L minus 1 minus 2J minus H. Put the values. 3L minus 1 minus 2J minus H. H कितना है बेटा? This is 0. Solve करेंगे तो I will be getting 3 3s are 9 minus 8. Degree of freedom is 1. What is the meaning of degree of freedom 1? Degree of freedom 1 means that in this mechanism, if we want to, provide constrained relative motion between all these links, or we can say if we want to have unique output, how many inputs are required? That number is given by degree of freedom. So in the mechanism की दुनिया में, in the field of mechanism, degree of freedom tells number of input required to get unique output. To get unique output. Like in this case, sir, if like in this situation, degree of freedom I have got the one. It means that if only one link ko you provide motion, giving input means providing the motion. So for any one link, say for example link 2 ko I have provided motion. Here I have connected motor and I am giving some motion to link number 2. So if I have decided link 2 ka motion kya hoga, what will be motion of link 2? So link 3, link 4, all other remaining links, they will move in a constrained fashion. They will not have a choice. I want to move in this direction, this direction. No, they all are governed by this motion. So link 2 ko you have moved with some velocity. So link 3, link 4 ka velocity kya hoga? What will be velocities of the link 3 and 4? That is fixed. I can get motion of this link 4 as my output. So here, if you want to have output, only one motion, here only, just give motion to link number 2. You will get all the constraint motions. समझ रहे हैं? On the other hand, suppose if I have another situation कि sir, link number 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5 and 5 is connected to 1. We may have situation like this. Another case, pin joint, pin joint, pin joint, pin joint, pin joint. I am having this situation. Now again, do the same thing. Achha, this is a chain. First of all, I must fix something. Link 1 fixed hai. Link number 1, link number 2, link number 3, link number 4, and this is link number 5. Calculate kariye using same formula. Can you tell me what is the degree of freedom? Tell me in the chat box, what is the degree of freedom? Degree of freedom ka formula, let me write. 3L minus 1 minus 2J minus H. Put the values, how many links you have, how many kinematic, how many lower pairs we are having. Yes, Abhijit, every subject will be covered. This entire series. Dekho, today I have started this thing. And how is your response? How many people are loving these series? And then we will definitely continue this one. Can you tell me what is the answer here? Although this is happening in the YouTube, that doesn't mean that you are just lying on your bed and enjoying the web series. This is not a web series. You must have copy pen, and whatever I'm asking, you have to give the answers. Even those people who are watching this series, this YouTube lectures in recording format, you must also give the answers. What is the answer? Sir, 2 aa raha hai. Kaise? How many links we are having? Sir, number of links I can see 1, 2, 3, 4, 5. How many lower pairs? Pin joints kitne beta? How many pin joints? I am having 1, 2, 3, 4, 5. So there are total 5 joints. Do we have any higher pair? Sir, there is no higher pair. Put the values. Degree of freedom F is equal to 3 L minus 1 minus 2J minus H. Degree of freedom is coming out to be 2. Great. Many of you have got the answer. Clear? So how we are solving these questions, I hope it is very, very clear to everyone. Now sir, what is the meaning of higher pair? I am not able to understand. Higher pair kaisa dikhta hai? How does it look? Say for example, if I am having a cam and follower device, I am having a cam which is hinged here. With respect to fixed link, this cam can have rotation. It is rotating like this. And then I have a follower. Follower kaisa hai? Sir, this is the follower. Knife edge follower. How does it look? Sir, it looks like this. Knife edge follower looks like this. So this cam rotates and because of the rotation of the cam, this follower moves up down, and this follower, I have kept this follower inside a slot, guide walls. Okay, fixed link. Can you see what is happening here? This is something which is called as follower. Follower is inside the guide walls. है ना? Inside some slot I have put the follower. Now follower is not able to come out. It will always be having this up down motion inside the fixed link. So how many, first of all, links we are having here? Sir, fixed wala body, this is called as link number 1. This is my link number 1. Link 1 के respect में cam can have rotation. I will say that this is link number 2. With respect to 2, link follower is moving. I will say that this is link number 3. Link 3 is moving with respect to this fixed body. Don't call it as link number 4. Fixed body is link 1. Fix, it is link 1 only. समझ रहे हैं? In this entire mechanism, this is fixed. This is fixed. So entire fixed thing will be treated as one single body, one single link. Okay. How many links you can see here, sir? There are, I can see 3 links are there. How many lower pairs are there? I just have told that in 2D mechanism, lower pairs you will be having either in the form of turning pair or in the form of sliding pair. So what you can see here, link 1, 2, they are having turning pair, sir, this side. So I am having between link 1, 2, I am having the turning pair, lower pair hai. Between link 3 and 1, I am having the sliding pair here. Between link 1 and 3, I am having sliding pair. You call it as 1, 3 as sliding pair or 3, 1 as sliding pair, nothing but same. So these are the 2 lower pairs. Do we have any higher pair? Yes, I have higher pair. Sir, between link 2 and 3, I have point contact here. This side I have point contact or line contact. Very less contact area is there. So this is something which is called as higher pair. Higher pair matlab between link 2 and 3, because it is having point or line contact, you will call it as higher pair. So how many higher pairs? Sir, only one higher pair I have. Put these values. Degree of freedom का formula होता है 3 L minus 1 minus 2 J minus H. Put the values. What is the degree of freedom? 3 L minus 1 minus 2 J. J का value is 2 minus H का value is 1. Degree of freedom is coming out to be how much? 1. So I hope everyone has got that how higher pair looks. Clear है बात? Beta, for aerospace we have started the paid batches, है ना? And if response is very good on the YouTube also, we will also start some series on the YouTube. Okay? If any technical team, backend team is watching this lecture, people are also demanding YouTube series for aerospace. Okay? Paid batches we have, paid courses we have started for aerospace. चलो ये बात समझ में आ रही है? Everybody is getting this now. So this was all about degree of freedom. Now coming to Grashoff's law. First of all, we are having simple mechanism. We are having 4-bar mechanism. How does it look? Sir, 4-bar mechanism, it means that you are having 4 links. All the links are connected with the help of pin joint. This is pin joint, pin joint, pin joint, pin joint. So this is something 4-bar kinematic chain. Now in this chain, if you are fixing something, you will be calling it as mechanism, 4-bar mechanism. Which link you want to fix? You can fix this, 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 or this. Any one link you can fix. Suppose I have fixed this link. So this is your fixed wala link. And adjacent to the fixed link, either this or this, you can give input here. Why? Because providing input is easy on that link whose at least one end is fixed. है ना? By at this fixed point, I have connected a motor, and with the help of this motor, this link can be rotated. So I am providing input with the help of some motor. and collecting the output. Sir, this link ka motion I am collecting as my output. So this is my output link, and this is your input wala link. Input link, and this is your output wala link. And what is this called as? Sir, this is something which is called as coupler. Coupler is just a link which is taking motion from input body and giving it to output wala link. Coupler, or also called as coupling rod. I hope this is clear. Now, in this mechanism, if you are looking for the input link and output link motion, what kind of motions these can have? So they are having pin joint here, fixed link, this point is fixed. So with respect to fixed point, input link can have rotation. And output, sir, this is also having pin joint, turning pair, it can have only rotation. Rotation if it is complete. If any link is having rotation, complete rotation, then I will call it as crank. On the other hand, if link cannot rotate completely, there are chances that link cannot make full circle. It can have only this motion, oscillation. If it is not having complete rotation, partial rotation if it is having, partial rotation or oscillation, then I will call it as it is rocker. So how crank moves, how rocker moves, I hope this is clear. Now question arises that, sir, in this mechanism, how we will decide that input is also doing crank complete rotation, output is also doing complete rotation? Acha, if input is rotating completely, output is also rotating completely, can I call this mechanism as this is also crank, this is also crank mechanism? Yes, you can call it as double crank mechanism. If only one is moving, if this is moving full rotation, this is not able to make complete rotation, this will be crank, this will be rocker. Or we may have a situation where both these links are not having complete rotation, this is also having oscillation, input is also having oscillation, I will call it as double rocker mechanism. So what kind of inversions are possible? We may have three possibilities. In the 4-bar chain, you have fixed link number 1 or link number 2 or link 3 or link 4, depending on either one fix kiya hai, or you have fixed 2, or you have fixed 3, or you have fixed link number 4. Sometimes people get confused, they say sir, link 1 ko I have fixed, okay, fixing link 2 also. Abe nahi, you are not fixing link 2 also. Either you have fixed link number 1, if not link 1, you have either fixed 2 or you have fixed 3. Any one link you have fixed, which one you have to decide. Now by fixing different links, we may get some different type of motions, that is called as inversion. So how many inversions are possible here? How many inversions are possible? Sir, first possibility is you have fixed such a beautiful link that adjacent input output both are having complete rotation. Crank mechanism, double crank or double crank. Sir, only one link is having rotation, other link is not able to make complete rotation, you will call it as crank rocker mechanism. Or we may have a situation, sir, neither input nor output, nothing is having complete rotation, then it is called as rocker mechanism. Crank mechanism, crank rocker mechanism, or rocker mechanism. Now when I will get crank mechanism, when I will get crank rocker mechanism, or when I will get rocker mechanism, how do we decide? This decision can be taken with the help of Grashoff's law. What does this Grashoff's law says? First of all, this law is only for 4-bar mechanism. You cannot apply this law in single slider crank mechanism, double slider crank mechanism, nowhere. This is only applicable for 4-bar mechanism. You must have 4 links, and all these 4 links must be connected with the help of turning pair. Then only this Grashoff's law is applicable. And based on some experiments, Mr. Grashoff has made some statement. What is the statement? He says, if you want to have continuous relative motion between the links, for continuous relative motion between links, summation of shortest plus longest link should not be more than summation of other two links. Other two links ko I am saying as P and Q. So if I have 4 links, one link is having some dimension, other link is having some dimension, all the 4 links ka dimensions are given. So what is the shortest link, what is the longest link? Identify that. Summation of length of shortest and longest link, it should not be more than summation of other two bodies. If this condition is holding true, then only there will be continuous relative motion between the links, and then only you can get crank. Kya condition hai? Like this, or you can also say it like the shortest plus longest should not be more. So what it can be? It can be less or it can be equal. So shortest plus longest should be less than or equal to P plus Q. I hope this is clear. And just having shortest plus longest link smaller than P plus Q doesn't guarantee you that your input and output will be having crank wala motion. It also depends. This condition must be fulfilled. Then I will check which link you have fixed, where you have made your input and output, because fixed link ke adjacent mein hi you are going to have input and output link. So let me further explain that. Sir, taking this Grashoff's a little ahead. Suppose you are having this situation. बहुत ध्यान से समझना. This kind of situation if we are having these 4 links. Pin joint, pin joint, pin joint, pin joint. We are having these pin joints. ठीक है? 1 situation, 2 situation, 3 situation. Careful. Suppose I have fixed, this is my shortest link, this is my longest link, and other 2 links ko I am calling it as just P and Q. ठीक है? Shortest, longest, P and Q. Shortest, longest, P and Q. So if any time you have fixed the shortest link ko if you have fixed, so fixed link ke adjacent, this side and this side, I can have input and output links. And if shortest link is fixed, both the links which are connected, this one and this one, this will also rotate completely, this will also rotate completely. Both links will have complete rotations, and this is called as crank mechanism. Your choice. Anywhere you can make input, then it will become output, or if you have provided input here, so it will be called as your output link. On the other hand, if shortest ke adjacent wala link is fixed, shortest ke adjacent, either this or this, fix any of the adjacent to the shortest link. If you have fixed, ध्यान से समझना, if you have fixed this link, so shortest will make rotation. Fixed ke both adjacent input output I can have. So fixed ke one side mein where we are having shortest, it can have complete rotation, but the other link will not be able to have complete rotation. It will have oscillation. Crank rocker mechanism. Or sir, shortest ke adjacent, not only this, even if you have fixed this link, what kind of motion you are going to get? Sir, fixed ke this side, you can have input and output link. So this particular link, it can have complete rotation, shortest one. Other link will not be able to have complete rotation. About this end, it will have rocker wala motion. So either this or this, I will say this, both are crank rocker bhai, crank rocker mechanism. And that's why I am saying that there are 4 links, but I am not getting 4 inversions here. Why? Because I was about to say 1 inversion, 2 inversion, 3 inversion, 4 inversion, but this inversion and this inversion, they are having similar motion. Here also crank rocker, here also I am getting crank rocker. So both these are different mechanisms, but single inversion. only one inversion. They are not different type of mechanisms. Clear hai baat? So one inversion, two inversion, and third inversion you may have. Sir, if shortest ke opposite wala link you have fixed, what you will get? Shortest ke opposite wala link if you have fixed. So shortest link about this end, it can have rotation. But I'm not looking about this rotation. I'm interested. Tell me what is my input and output link. Sir, fixed K, this side and this side. Input output can be provided. So none of these links can have complete rotation. About this end, this link will have oscillation, and about this end, this link will be having oscillation. Situation will be this. Tell me in the chat box. Is this clear to everyone? How this Greshoff's law can be asked? They will simply give you a mechanism. They will give all the dimensions, and they will simply ask the question, okay, tell me which kind of mechanism I'm going to get. Or sometimes they can miss some dimension, and they will say that what should be this dimension, what should be range of this dimension, so that crank rocker mechanism I can get, or double crank mechanism I can get. Okay, let me give you one question. This question have been asked in GATE 2020 mein pucha hai this question for 1 mark. What they are saying, a 4-bar mechanism is shown in the figure. For the mechanism to be a crank rocker mechanism, length of link PQ can be how much? This is PQ. What can be the length of this PQ link? They have given the 3 links ka dimension, 400 mm, 300 mm, 600 mm. I don't know what is this. This is X. What it can be? So that it is a crank rocker mechanism. Okay. So the very first possibility, this link, its dimension I don't know, but in the diagram itself it is looking like this. This is the shortest possible link. So if this is my shortest link, so shortest ke adjacent wala link fixed hai, it can be crank, it can be rocker. This kind of situation I can have, crank rocker mechanism. This must be a Grashof chain first of all. Then if it is fixed, I will have crank rocker mechanism. So just apply. This is the shortest link. What is the longest link you can see here? Longest link I can see here is 300, 400, 600. This is the longest link. Other links, P and Q, I will say. Kya ho jayega? Sir, shortest plus longest link should be less than or equal to P plus Q. What is the shortest? I have to find out. X plus longest ka value is 600. It should be less than or equal to P plus Q. Kitna ho jayega? But this is 400 plus 300. So X should be less than or equal to 700 minus 600, 100. So X ka value, it should be anything less than 100 value. Less than 100, where I am having 200, 300, 350, only option A is correct. So this is how you can solve this question. Tell me in the chats, is this clear to everyone? Are coupler, coupler to coupler, you are talking from the point of view of that car modification. Car may, if you want to have some modification, wirings may they use a term coupler to coupler joint. No, that is a different thing. They are talking about electrical connections. No. Here in my case, which I have said as coupler, which I have said coupler is something which is connecting input link and output link. That is coupler. You are asking coupler to coupler, I hope from the from the point of view of car modification. Okay, coupler to coupler joint. Chalo. So I hope this thing is clear to everyone. Now let's talk about what is degree of freedom. Everybody is clear. What is the Greshoff's law? How questions are asked? Sometimes they will ask simple question. They will simply ask question ki identify the mechanism. Batayega. This question is for you people. Identify the type of mechanism. Identify the type of mechanism. Careful. बताइए बेटा. I have one link which is the shortest link. Chalo, let me give the dimension. One link, another link, another link, another link. Those who have already studied, they can identify the, oh sir, this is the deltoid linkage. ठीक है. And if I have given the dimension, this is 20 centimeter, 20 centimeter, 60 centimeter, 60 centimeter. ठीक है. Let me fix any one link. Suppose I have fixed this link. This link is fixed. Can you identify which mechanism is this? Let me give the option. Option A, B, C, D. Is it a crank mechanism, crank rocker mechanism, rocker mechanism, or triple rocker mechanism? What kind of mechanism is this? बताइए. Just check. First of all, just check whether it is a Grashof chain or not. मतलब shortest plus longest का summation and P plus Q का summation. Is this less or equal? Grashof's law is holding or not? Shortest link is 20. If you are calling it as shortest link, longest link is this. Other links will be P and Q. This is P and this is Q. क्या हो जाएगा? Shortest plus longest कितना है? 20 plus 60. Other two links are also 20 and 60. Sir, this is actually equal. It means it is a Grashof chain. And if it is a Grashof chain, this is a Grashof chain. It is following the Grashof's law. Now check which link is fixed. Sir, shortest link is fixed. So what mechanism you are going to get? Shortest ke adjacent. This one will rotate. This will also rotate. What mechanism you are going to get? I am getting crank mechanism. I hope this is clear to everyone. But sir, what if it is a non-Grashof chain? Another example. Let me take another example. Sometimes in hurry, many people, without checking whether it is Grashof chain or not, they simply look which link is fixed and they give the answers. No, it is wrong way. You can have mistake. Let me give you another situation. One link, another link, another link, another link. Dimensions which I have given, this is a 4-bar chain. Pin joints I have, these are the pin joints. Dimensions are, all the dimensions are in centimeter. Dimensions I have given as 10 centimeter, 70 centimeter. ठीक है. 40 and this is 30. ठीक है. And if I have fixed this link, again, can you repeat the question? What is the nature of the mechanism? Option A, B, C, D. Whether it is crank rocker, rocker, or triple rocker. Which kind of mechanism is this, beta? Tell me what is the answer? Correct answer. बताइए. Anyone? Sir, I can see this is my shortest link, 70 is my longest link, and these are P and Q. But before you say that shortest ke adjacent wala is fixed, the shortest will make rotation, it will have rocker wala motion. This is a crank rocker mechanism. Before you say which is fixed, you must check whether it is Grashof chain or not. Check karo shortest plus longest and P plus Q. Is it less than or equal? Shortest क्या है? This is 10. Longest क्या है? 70. This is 80. P plus Q कितना है बेटा? This is 40 plus 30. It is 70. So actually it is larger. It should not have happened. That means it is non-Grashof chain. Non-Grashof chain. If it is non-Grashof chain, doesn't matter which link you have fixed. Fix this one or this one or this one or this one. You will get no link which can have complete rotation. In fact, between the links there is no continuous relative motion. So this mechanism is called as triple rocker mechanism. This is called as triple rocker mechanism. What is the meaning of triple rocker? Triple rocker means fixed ke adjacent, this one, it will have oscillation. Fixed ke other side mein, this, it will have also oscillation. Sir, then you must say rocker rocker na? Nahi. Even this link will not have complete rotation. Earlier, in this case, what I have said, sir, in this case, what I have said, it was Grashof chain, but shortest ke opposite wala is fixed. So this fixed link ke both the adjacent links, input output links, they are having rocker type motion, oscillation type of motion. They are not having complete rotation. But this link about this pin joint, it was having rotation, complete rotation. I cannot use that. That's a different thing. But it is having rotation. In this case, input output they are rocker. Even this link cannot make. Coupler is also not having rotation. That's why it is input bhi rocker hai, output is also rocker, even the third link is also rocker. Triple rocker, we call it as triple rocker mechanism. I hope difference is clear to everyone. So based on Grashof's, how questions are asked. Now coming to our next topic, quick return motion mechanism. From the name itself, this is quick return motion mechanism. From the name itself, it is very clear that this mechanism is having something which is something very special. Quick return. Like there are so many industrial situations where I need this kind of motion, where machine has to do repeated type of motion. Some machine is having motion where one side say when machine moves, it is having working stroke, it is performing some job. Then after performing this job, machine just have to come back to its original position so that it can repeat the next cycle. It can be ready for the next cycle. So while we are performing some work, I'll be having some speed, and that speed will be decided based on so many parameters. Like if I'm having cutting operation, so doing cutting operation, my tool is moving and this tool is doing cutting. So what speed I should have for the cutting, that will be decided by the manufacturing process wala teacher, like Aditya sir, Swadesh sir. They will be deciding that at what speed you must do cutting, because cutting speed unnecessary, you cannot make cutting speed too low or too high, because very high cutting speeds, surface finish may improve but the power consumption increases. So there will be some optimum cutting speed which you have to have. Who will decide this? Some manufacturing experts will decide this cutting speed. But once your cutter is moving in this direction, it is having cutting. Now cutting is done. Now your cutter is just coming back so that next cutting stroke can be performed. So when this is coming back, I want this return wala stroke to be a little fast so that my productivity can be increased. Productivity increase karne ke liye I want to have my processes fast. Cutting stroke, working stroke, you cannot make it faster. Why? Because it has some constraints. Who is having this? Who is giving the constraints? Sir, manufacturing experts have told me that cutting should be at this speed only. That's it. No discussion on that. Okay, sir. ठीक है. Returning me, I'm just coming back empty-handed. So I'll be coming back fast. बात समझ में आ रही है? क्या मतलब है? जैसे you can imagine it like if I'm a worker, I'm having some work, and this is a man, and I have to. There are so many bricks. I have to put these bricks from one space to another space. From here, I have to shift the bricks. So when I'm having some bricks on my head, so sir, my capacity is to have only these 2 bricks. 2 bricks I have in my head. In my head, yellow. On my head, I have these 2 bricks. I have some load, and I'm moving here. So this is my working stroke. Working, you know. From here, I'm moving. So this is my working stroke. I'm giving this side working stroke. But once I have unloaded these 2 bricks, again now I'm empty headed. I have no load on my head. Now, because I was earlier having load, so I was moving slowly. Sir, I cannot run faster because I have huge load. But while you are coming back, I want, "Arey bhaiya, come fast, run." So while coming back, you are actually having high velocities. You are coming fast. Why? So that next working stroke you can perform quickly. This is how we can increase the productivity. Common sense वाली बात, productivity को increase करने के लिए we are doing this. Working stroke, do at your own speed. Return stroke, do it as fast as possible. है ना? Or at least faster than the working stroke. Whatever time you have taken in working stroke, return stroke में you should take something smaller than this. Is this clear to everyone? And if this kind of thing is happening in the mechanism, so that mechanism which can provide this, this kind of motion, I will say that this is your quick return motion mechanism. And very popular quick return motion mechanism is single threaded crank mechanism का inversion. कैसे काम करता है? How does it work? Let me show you this. First of all, I'm having this link number 1. Link 1 के साथ में we are having this link number 2. Link 2 के साथ में we are having link number 3. And link 3 के साथ में we are having link number 4. This is my link number 4. ठीक है ना? Very, very careful. Pin joint. This is also pin joint. बहुत ध्यान से. This is single threaded crank mechanism. And I can fix either this link, cylinder fixed. What will happen? Crank will rotate and the slider will have reciprocating motion. This is how your IC engine is going to work. Compressors are going to work. One type of mechanism you have got, one inversion. So cylinder fix, you have got something. Crank को fix करेंगे, you will get some kind of motion. If you fix the connecting rod, from here I can get the quick return motion mechanism. Acha, I have used different colors so that it will be easy for you to recognize this is the mechanism, but in reality, how I am using it, I can change the orientation. That some link which is horizontal here, I can make it vertical. Orientation I can change. Color coding I will make it same so that you can identify ki, oh, this is red link, so here I will show that link with red color only. Shape I can change. How will you feel that, sir, orientation you have changed, shape you have changed, then how will I feel that this one and this one is same or not? Just cross check it like this, that suppose this is fixed link number 1, link 1, link 2, this is link 3 and this is link 4. So whatever pairs I have maintained here, like link 1 and 2, they are having pin joint here, turning pair. 2 and 3, they are also having turning pair. Link 1 and 4, sir, they are also having turning pair. Between 3 and 4, I am having sliding pair. So whatever mechanism now I will make, whatever machine now I will make, it will have this kind of pair only. So pairs I will maintain the same. How I am doing this? Link 1 को I have done fixed. बहुत ध्यान से देखिएगा. Link 1 को I have made fixed. Here, this is my link number 1. This is my fixed link. Yellow, this link 1 is fixed. Link 1 के one end पे I have connected link 2 which can have rotation here. Yellow जी. Link 1 के one end पे I have connected link 2. Link 2 can have rotation. This is link 2. It is having rotation. अच्छा, what kind of motion you can get? Let me explain it. Sir, shortest link के adjacent वाला is fixed. So shortest can have rotation, crank, and other link it cannot have complete rotation. It will have reciprocating type of motion. So link 4, link 1 के end पे pin joint से it is connected. So it will not be able to have full rotation. Now it will have this kind of oscillation. So this will behave as crank. Link 4 will behave as rocker. How I am showing it? Sir, yellow, this is your link number 1. Link 1 के साथ में I am having link number 2. बहुत ध्यान से समझना. I will explain one quick return motion mechanism, and similarly you are having other varieties also. So just understand only one thing. Other things with the help of books you can by yourself understand. So link 1 के respect में link 2 is there. Link 2 के साथ में we are having link 3. Pin joint से there is a link. So here with the help of pin joint I will connect another link. Red color का link है. So I have made red color का link like this. This is my red color का link. Sir, अरे you are showing link 3 as slider. I can change the shape. You just keep focus that link 1 2 turning pair है क्या? Yes. 2 and 3 is it also turning pair? Yes. This is link number 3. अच्छा, what about the link 4? 1 के other end पे I am having link 4. Link 1 के other end पे here I am having link number 4. Yellow color से I have shown the link 4. So link 4 कैसा है भाई? Sir, link 4 is here. I will connect link number 4 yellow color का. This is the link. ये link 4 है. With the help of pin joint I have connected this. And link 4 and 3 they are connected in such a way that they will be having sliding between them. Sliding हो रही है. Sir, something like this. The link 4 which I have shown here, actually it is a slotted link. Slotted link कैसा नजर आता है? The slotted link looks like this. We will be having a slotted link like this. ये slotted link है. Slotted link को here you have hinged. At this hinge point, link 4 can have this oscillation wala motion. It will be having this oscillation wala motion. And inside the link number 4, we are having a red color ka body which can have sliding motion inside it. Sir, actual situation is this. This is my link number. Red color ka link is link number 3. So I have shown it like link 3 and link 4. But real situation is like this. Link 4 is a slotted link. Inside it there is a slider which is kept. बात समझ में आ रही है? So I have shown it like this. Real situation is this. How many of you can feel it? Now, how this mechanism is going to work? Sir, in this mechanism, if you connect a motor here, motor will rotate link 2 completely. It will rotate completely. Link 1 के respect में link 2 will have complete rotation. It will behave as crank. Link 1 के other end पे I have something. This link. It will have oscillation wala motion. बात समझ में आ रही है? So this mechanism I have shown it like this. Now, sir, which point here is having quick return motion? Let me show you that. Can I remove all this? Now focus only on this mechanism. बहुत ध्यान से. Sir, can I say simply one thing? That if I connect a motor, link 2 will rotate. Link 2 will rotate. So at the end of the link 2 pin joint say I have connected link 3. So this pin joint or this slider, it will move along this circle path. So what circle में this link 3 is going to have motion. It will be moving along this. Is this visible to everyone? A thin circle I have made. So link 2 ka end point, let me give it some name. Let me give it some name. This is, suppose this is point O, this is point A, this is point B, and this end point of this link, it is point C. I'm saying this is your point C. So when you have connected a motor which is rotating with some omega angular speed, can you say this point A is moving along this circular path? Point A is moving, that means slider have to move along the circular path. But slider, sir, slider have to be inside this link number 4. So wherever slider will go, it will take this slotted link along with it. Obviously baat hai. But sir, slotted link, it is to make rocker type of motion. It will go this side and it will stop somewhere. It cannot go further beyond. So extreme positions of the slotted link, if I want to show, it will be something like this. Sir, from here, the slotted link max to max, it can go tangential to the circle. Beyond the circle, it cannot go. Why? Sir, slider is on the circle only. So for slotted link, it cannot go beyond the circle because slider have to be inside the slotted link. And one extreme position I have shown it here. Other extreme position, if I want to show, other position will be tangential this side to the circle. Tell me in the chat box. Is this clear? You can clearly visualize this thing. Now, whenever your slotted link is at these two extreme positions, these positions are called as toggle position, end positions. Okay, this is the toggle position. This one also, this one also. This is also toggle position. Extreme position of any rocker is called as toggle position. Toggle position पे obviously बात है, rocker का velocity is going to be 0. It has stopped here. It will again come back. It will stop here. Again it will come back like this. So this kind of motion it is going to have. And if I talk about the motion of the this link, rocker wala link, its velocity is 0 here. Now its velocity increases somewhere in between its maximum velocity we are going to have. And then again half of the, during half of the motion its velocity increases, reaches maximum, and rest half of the motion its velocity decreases gently, and at the end it is 0. Again its velocity will increase, at the midpoint it will be having maximum velocity, and then slowly it decreases to 0. So this kind of motion it is going to have. Careful, careful. These are the two extreme positions. Now corresponding crank का position क्या है sir? When crank is here, for one situation crank is here, it means when point A is at this location, yani ki slider is at this location A1, so this slotted link will be here. Look at this point C. C will be here at C1 position, and when your crank moves from here to somewhere this location, crank has moved from here to here. Can I say, sir, at this position, point A is at A2 location. So where will be point C? C will be here at this C2 location. So whenever crank is here, slotted link have to be this side. Crank is here, slotted link have to be that side. Yani ki point A is at A1, C must be at C1. Point A is at A2, point C must be at C2 position. ध्यान से समझना. Your crank is connected with motor, it is rotating with constant angular velocity. So for moving from point C1 to C2, sir, C1 से C2, from this C1 point to C2 point, if you are moving like this in this direction, so for A1 to A2 you have traveled clockwise direction में this angle. What is this angle beta? Sir, this angle you have traveled some larger angle. You are calling it as some angle beta. and you are moving clockwise now. For returning from A2 say A1, you are making only a very smaller angle alpha, and from A2 say A1, once you will move immediately from C2 say C1 you will move. Boliye. So from C1 to C2 you are moving when the crank is traveling this big angle. Obviously it will take more time, and for returning A2 say A1 you are traveling only smaller angle. A smaller angle, it means you will be traveling faster. Sir, crank is making bigger angle, crank is making smaller angle. It is moving with same velocity. Same velocity. So time taken for this angle is more. Time taken for this angle is smaller. It means from here to here you will move slowly, but for this return wala motion you will be a little faster. You will take lesser time. So what point here is actually doing quick return motion? Sir, point C का motion is quick return motion. समझ पा रहे हैं? And once you see that point C here is doing quick return motion, how you can decide? Sir, beta angle is more than alpha. Beta is more than alpha. Whenever you see any mechanism, one side का angle is smaller than the other side का angle. This mechanism can be used as quick return motion mechanism. Now, if to use this mechanism for any purpose, say for example, I want to make my shaper machine. Shaper machine, we are having a cutter. That cutter moves like this, doing cutting operation. And while coming back, I want it to be faster. So it moves slowly, doing cutting operation, and then comes fast, returns fast. So for that, this is the quick return mechanism. Now at point C, I have, with the help of some link, I have connected pin joint. Say I have connected a link, and on this link I have connected again with the help of pin joint a tool post where I'll be connecting a tool. Tool matlab some cutting tool. So suppose this is the cutting tool, and this entire setup I have forced it to move on this horizontal path. How it is forced to move on the horizontal path? Obviously there must be some slotted, fixed slot you have provided. On this fixed slot it is going to have motion. समझ पा रहे हैं मेरी बात? Are you getting? So this is the fixed link. On the fixed link, this cutter is going to move. Is this clear to everyone? Clear hai? So cutter, or you can call it as ram. So extreme position of the rams will be where? Sir, for one situation, when point C is at C1, backmost position, so cutter will also be at the backmost position. On the other hand, when we are having point C is at C2, so cutter will also be at the farmost position. So these are the two positions of the ram. Ram will be at R1 and R2 positions sometimes. So from R1 say R2, I am having cutting stroke. R1 say R2, I am having cutting stroke. Cutting or working stroke? Forward stroke. On the other hand, this side, I am saying it as my return stroke, or people also call it as backward stroke. Everybody is getting my point? Examination mein, they will ask few questions about this mechanism. They will ask, what is the quick return ratio of the mechanism? What is the quick return ratio? Kya hota hai first of all? How effective is your quick return mechanism? To define that, we have defined a parameter, performance parameter. Quick return ratio is defined as time taken for the cutting or the forward stroke divided by time taken in the return wala stroke. Now how much time we have taken in the cutting stroke? Sir, cutting में कितना time लगा होगा? भाई cutting का मतलब from R1 to R2 cutting is happening. यानी कि from C1 to C2 how much time you have taken? C1 to C2 मतलब from A1 position to A2 position you are moving with omega velocity traveling beta angle. So beta angle को travel करने में, to travel this beta angle with the omega velocity, how much time we have taken? Sir, beta divided by omega. And for the returning, to travel this alpha angle with the same omega velocity, alpha divided by omega, this is the time. Omegas are the same. So can I write quick return ratio is beta by alpha. Simple सा क्वेश्चन है ना. Quick return ratio, just find out what is the beta, what is the alpha, and these two angles, how can I find out? Just with the help of the geometry. Sir, I have geometry in front of me. Geometry say, you can clearly say this is the 90-degree angle beta. What is the half angle? Sir, this is nothing but alpha by 2. And this is the triangle, right angle triangle, where this angle is 90 degree. Yeah, this is the alpha by 2 angle. This dimension is radius r. Sir, this is radius r, and the green link is the connecting rod, whose length is called as length L. So they will give what is the radius of the crank, what is the fixed link dimension. Can you identify, can you find out from the geometry itself what is the value of alpha? What is the value of alpha by 2? You can very easily solve it. Sir, I can write cos alpha by 2 is base upon hypotenuse. In this right angle triangle, can I write? It is nothing but r by L. Geometries are given, r and L is given. Can you find out what is the alpha by 2? Alpha by 2 is given, so you can find out what is the alpha. And once you have alpha, even a blind person can see that alpha plus beta is 360. Sir, alpha plus beta is 360 degree. So from here, what is the value of beta? You can identify that. You know the alpha, you know the beta. Can you find out what is the beta by alpha? Quick return ratio. Or reverse of that you can do. Sir, examination mein sometimes they will be giving the quick return ratio. What is the quick return ratio? For my mechanism, quick return ratio is something 2:1. Sir, quick return ratio always it will be more than 1. है ना? Obviously, बात है, beta is more than alpha. So they have given the quick return ratio. Beta by alpha का value they have given, suppose 2, 3, whatever. 2 they have given. So beta by alpha का value they have given. So reverse they will ask, beta by alpha का value they have given. Beta plus alpha, already you know 360 degree. So what is beta, what is alpha, you can find out. And once you know the alpha, so cos alpha by 2 is r by L. Any of the dimension they will miss. So they will either give the dimensions and they will ask you calculate what is the quick return ratio, or they can ask the reverse question. They will give the quick return ratio and they will ask, find out what is the missing dimension, radius r or L. They will miss any of these things. Clear hai baat? So first question they will ask like this. Second question, in this same quick return motion mechanism, they can ask, tell me what is the stroke. क्या हो जाएगा stroke बेटा? Let me remove all these things. How do I find the stroke का value बेटा? Stroke कैसे निकाल सकते हैं? Again from the geometry. If you are comfortable with the diagram, how I have made the diagram, there is nothing in this question. Sir, they are asking stroke in the question. What is the value of stroke? Stroke. Sir, from R1 say R2, this is your stroke. This is the stroke का value. Stroke को I am writing as S. What is the value of stroke? Stroke can be written as, it is nothing but R1 R2. अच्छा, R1 R2, if you look closely, so this is a parallelogram linkage. This is a parallelogram. है ना? If I connect this C1 C2 dimension like this, so you will see that this is actually a parallelogram. यानी कि this dimension is same as this dimension. So R1 R2 is same as C1 C2. It is same as C1 C2. C1 C2. And do one thing. From point B, this green color link, just extend this. Again, because we are having symmetry. Sir, this. If you will draw this line, can you say, sir, this line is getting bisected and this angle is nothing but 90 degree. Yes, beta. Khatam baat. This is the 90 degree angle. Right angle triangle hai. Now look at this triangle also. This triangle earlier I have seen. It is also right angle triangle. Yeah, this is angle 90 degree. half of the angle is alpha by 2. So this remaining angle is 90 minus alpha by 2. Now focus on the bigger angle, bigger triangle. This is 90 minus alpha by 2. This is 90. So what is this angle beta? This is angle alpha by 2. Can I say this angle I can see as alpha by 2 angle? And C1, C2 go you can write, suppose this is midpoint of C1, C2. So I can write as twice of MC2, double of this. And MC2 I can write, कैसे लिखेंगे भाई? MC2 can be written as this slotted link ka dimension if you know. Alpha by 2 angle if you know. From the geometry alpha, beta we can find out. So this dimension you know, this alpha you know, this its cos component can I write? BC2 cos alpha by 2. 2 into BC2 cos alpha by 2. Khatam baat. This is nothing but your stroke. So if again from the geometry, if you know what is the slotted link, what is the angles alpha by 2, can you calculate this half value? Yes. Can you double this? Yes. This is nothing but a stroke. Simple si baat. I am not giving you any formula. This is not a formula. I am just telling that geometries are important here. ठीक है ना? अच्छा, if you want, there is a formula also. People call it as formula, but all my student, I want you people to understand this geometry. Whenever questions are asked, you will draw the geometry. You will, do the geometrical calculation and find out what is the stroke, what is the angle alpha, beta, everything. Cos alpha by 2 go. If you want, you can write from this triangle. Cos alpha by 2 को you can write base upon hypotenuse R by L. लिख सकते हैं क्या? Sir, cos alpha by 2 को we can write R by L. I just have written R by L. लिख दीजिए. Formula, it is 2 into BC2 into R by L. What is the BC2? Sir, BC2 is nothing but length of the slotted link. लिख सकते हैं क्या? So my entire formula is 2 into length of slotted link multiplied by this R is radius of crank. Radius of crank divided by what is this L? Length of connecting rod. Length of connecting rod. Connecting rod is that particular link which you have fixed. You can also call it as length of the fixed link. So this is how stroke ka formula we will get. I am not saying that remember this formula. I am just saying that books mein this thing is mentioned as formula. Exam mein if they have asked, tell me what is the formula. So you can have this thing. Otherwise for solving, I will never recommend my student to remember this formula. This is not a formula. Those who know me, they know in my entire subject, I have never said that this is a formula. Remember this. Entire theory of machine is all about geometries. If you are comfortable with the diagrams, conceptual clarity is needed. That's it. You shouldn't remember anything. Only the diagrams. Offset slider crank mechanism, you are getting different answer. But all the questions have been already solved. है ना? Questions have been already solved. Chalo. Let me discuss your question. That question you are talking about, I think that question is this. है ना? Luckily, whatever you are asking in the chat, luckily I was having this question in my slide also. So question में offset slider crank mechanism के बारे में student is asking, and those who don't know what is the offset slider crank mechanism, sir, I have crank which is moving about the center, and line of motion of the slider is not here. It is a little offset. How much? 10 mm offset. crank dimension is 20 and this is 40. They are asking find out the quick return ratio. Sir, here similar to the previous case, you have connected a cutter on this slider के ऊपर. I will mount a cutter and cutter का motion, this side motion I will say at cutting stroke, returning में I will say that this is your backward stroke. समझ पा रहे हैं? How do we solve any quick return motion mechanism वाला क्वेश्चन? सर, just draw cutter का extreme positions, R1 R2 positions कहाँ होंगी, corresponding crank will be where, then try to see what is beta, what is alpha angle, है ना? So I am just trying to solve your question बेटा. Let me draw. क्या दिया हुआ है क्वेश्चन में? You are having, this is the link, this is the line of motion of this slider which it was supposed to be, but it is a little offset. Offset can be above or below. ठीक है? Where is the crank? Sir, crank is here. 20 mm का crank है. This is rotating and somewhere it is here. Sometimes it is here. And then we are having 40 mm का dimension. This is 40. Just double of this. So this is my radius R. This is length L. ये 40 है. This is 20. ठीक है ना? And I am having a slider here. Yellow जी. This is the slider. Here I have connected the cutter also. This is the pin joint. This is the pin joint. This is the pin joint. Clear है बात? ठीक है? But I am talking to you. The person who has asked me question, I am talking to you. This offset का value they have given 10. Take your calculator out. I don't have calculator. Calculation के लिए I will be depending on you. First of all, make, where is the forward stroke? Sir, forward stroke is here. Cutting is happening in this direction. Returning is this side. We are having return this side. Clear है बात? Sir, if I connect a motor, motor will rotate this crank. Crank will rotate on this circular path. Obvious सी बात है. ठीक है? And when our cutter is moving here, extreme positions of the cutter, when I will get extreme positions, you will get whenever your crank and connecting rod they become linear. Either they are making 180-degree angle between them or 0-degree angle between them. This cutter will be either at the farthest or at the backmost position of it. So first position I will make, when my, let me give it some name. Suppose this is point O, this is your point A, and this I am saying as point B. So when my, this crank is somewhere here, and just in line to this, I am having my connecting rod. So this is my crank ka position, and just in line to it, 180-degree in line, I am having my connecting rod. So my cutter extreme position is this position, है ना? Let me say that this is, if this is your point A is at A1, so this point B will be B1. Another extreme position, this is the farthest position. Crank and connecting rod has become 180-degree वाला inline. Another position. इधर आ जाओ. Sir, this crank, when it is at the back somewhere here. So where is the point A? Point A has moved at this location. This is your A2 location. Connecting rod, it is on it again in line, but it is making 0-degree angle. So this looks like this. ऐसा कुछ नजर आएगा. Let me correct this a little bit. This is your connecting rod. And point A is here, A2 point. Crank is this side. Let me zoom this a little bit. Sir, what I have shown here, my crank has moved this side. Point A is at A2 location, and just above it, my crank is here, and just on it, my connecting rod is there. This I have made. Both are just coinciding. That's why you are seeing only one line, but I have drawn two lines. I hope you can see this clearly. So extreme positions I have drawn, and corresponding point B, cutter will be somewhere here at B2 location. What is cutting stroke? From B2 say B1, B2 to B1 I am moving. That is your cutting. Check karo. Sir, if you have connected motor in such a way that from the A1 position of the crank to the A2 position of the crank, either you can move two ways, either this angle, or you can move anti-clockwise traveling this angle. How do you want to travel? Sir, from B2 say B1, I want to travel the bigger angle. B2 से B1 I am having cutting stroke ना, so A2 position से A1 position तक I want to travel the bigger angle. मतलब from A2 position to the A1 position I want to travel this angle. So this angle I will make it as my beta angle. This is my beta angle, and the remaining smaller angle, it will be your alpha angle. How do I get the beta and alpha? Sir, if this small gap, it is delta angle. So can I simply write beta is nothing but 180 plus delta angle, and alpha is nothing but 180 minus alpha angle, minus delta angle, 180 minus delta angle. So somehow we have to find out what is the value of delta. Once you have delta with you, 180 plus delta beta, 180 minus delta is alpha. Quick return ratio they are asking. कितना हो जाएगा? Beta by alpha. खत्म बात. Delta how I can identify? Sir, from this geometry, take few things out. Sir, this big geometry, I'm taking few things out. Kya? Can I say? From this center, this entire line, what is this? Sir, this is radius r plus length l. बोल सकते हैं क्या? Sir, this from this point till this point, this is r plus l. What is the radius r? R plus l, 20 plus 40. This is 60. Take another line from here. I am taking this line out. What is this line? Sir, this line is actually from here. Total was length L, and if you subtract radius R, so total L minus R, you are left with this value. What is this value? Sir, this value is L minus R. Yes or no? And this is the line of stroke. ऐसे ही तो बोल रहे हैं आप. Can I make this diagram a little bigger? We are having this kind of situation. This is your point, you are saying as point O. The angle in between is, you are calling it as delta. These dimensions which you have got, this is 40 plus 20, which is 60. It is 40 minus 20, which is 20. This is your point B2, and this is your point B1. And this dimension how much it is beta? Sir, this you are saying at offset 10. ये है हमारा offset 10. This is my 90-degree angle. How can I find delta? Sir, simple सी बात. Can I write this bigger angle theta 1 minus this smaller angle which you are saying as theta 2? Theta 2 minus theta 1. Can I write? Sir, delta is nothing but theta 2 minus theta 1. What is the problem here? How do I get the theta 2? Simple geometry. Sir, theta 2 कितना है? Theta 1 minus theta 2. Sorry. Theta 1 minus theta 2. Theta 1 minus theta 2. Theta 1 is bigger angle, na? Theta 1 is bigger angle. Bigger angle, how do I get? Look at this big triangle. How do I get this? Sir, cos theta 1 is base upon hypotenuse. 10 upon 60. लिख सकते हैं क्या? So theta 1 is cos inverse 10 upon 60 minus, what is the theta 2 ka value? Sir, theta 2 ka value is this. From this triangle, can I write cos theta 2 is base upon hypotenuse 20. So cos inverse theta will be cos inverse 10 upon 20. From the calculator, tell me what is the value of delta, and whatever delta ka value you are getting, 180 plus delta is beta, 180 minus delta is alpha. Tell me in the chat box. What is the value of delta, beta? Dayanath, what is the value of delta? You will get some value of delta by cos inverse 10 by 20, cos inverse half 60 degree. ये value है, this is 60 degree. ठीक है, this is coming out to be 60 degree. Cos inverse 1 by 6. Tell me what is the value? Difference कितना हो जाएगा? You will get some delta, and once you have delta with you, so what will be quick return ratio? Sir, 180 plus delta, 180 minus delta. That's it. कितनी value आएगी? It will be 1.25 something. This is not tough. This is not tough at all. It is just geometry. If somebody thinks that you will remember these things, no, it is not possible at all. So much complicated things are there in the entire theory of machine. Just understand the concept. Just try to remember the diagrams. That's it. That's it. That's it. This is the correct way to handle the situation. ठीक है? Chalo. So today we have talked about degree of freedom. Today we have talked about what is the value of this? 1.40. अरे नहीं 1.40 नहीं आएगा. Delta का value you will find something. Quick return ratio, then you will get. ठीक है? This is my Telegram group. Vishvajeet sir, PW, if you will find this. So whatever doubts you have in your preparation, you can ask me there. There are 4,000, 5,000 members, 4,000, 5,000 mechanical engineers who are preparing currently for GATE examination. है ना? So like-minded people are there. You can have your doubts. You can connect with me directly there. And the major question, ki sir, I have studied things now where I can do my practice. Like in this YouTube session also, you asked one question. It was PYQ, but you were not having correct answer. So how can you get the correct answers? And sir, even if some books make answers are mentioned, but I have still some doubt. I want you to discuss live. So you can have these, PYQ's book prepared by Physics Wallah, GATE Wallah. These books may we have provided the, error-free solutions. You have every chapter wise, chapter may be topic wise questions. For the practice, for the sake of practice, it is, just awesome. So chapter wise, chapter ke andar, topic wise, you are having questions. Segregation is beautifully done. If you want to solve questions of quick return motion mechanism, you will be having. If you want to solve questions of degree of freedom, you will be having all the degree of freedom questions at one place. Every question ka answer is given written format. If you can understand, just by looking at the solution. If you are still not getting this, just at the side of the solution, you are having a QR code. Scan that, and the teacher will be in front of you. You will be sent to a video. In that video, you will be having that video solution. Video solution may, like, sir, PDF may I am not able to understand. You have simply written this formula, but I am not convinced why you are using this formula. Can you explain this? So that explanation live in front of you will be done, in that video. So have you seen Harry Potter's ka movie? Harry Potter movie mein we used to have that newspaper where images were moving, and sometimes I see these books where question is there, solution is there, and then a QR code, just scan it and a video will pop up. I sometimes feel that Harry Potter movie has, become truth. Okay? So, chaliye, that's all. It was about simple mechanism. Tomorrow, we will, same time, at the same time, 8 p.m, we will meet again, and I will discuss a further chapter about velocity analysis. Velocity analysis mein, what are the concepts which are usually asked in GATE? What is the eye-center? How do we find out the location of the eye-center? What is the Kennedy's theorem? Everything we will discuss, and we will also solve some beautiful PYQs so that you will get a clear idea how actually GATE exam is going to ask question on these topics. Okay, let's stop. Tomorrow sharp at 8 we are going to meet. Till that time, thank you, bacho. Goodbye. Love you all, Meri Jaan.